Trigonometry, Chapter 4, Graphs of the Circular Functions, Section 1, Graphs of the Sine and Cosine Functions, Video 7, Determining the Function for a Graph, Amplitude and Period. This series is based on content from Pearson's Trigonometry 12th edition by Lial, Hornsby, Schneider, and Daniels. Come on. There we go. All right. In the previous videos, we developed the graphs for both sine and cosine. We investigated how to change the period and amplitude of both. In this video, we analyzed the graph of a sine or cosine function to determine a possible function for that graph. Consider the graph below. It's one cycle of a trig function's graph. Can we determine a function for this graph? Well, of course we can. But how? We can, but we need to analyze four main features of the graph. First, would this be sine or cosine? Now, before we continue, for this video, we assume there have been no horizontal translations left or right. We will assume the only transformations are changes in the period, so stretch horizontally, changes in the amplitude, stretch vertically, and possible reflections across the x-axis. We will address translations in future videos. But for now, would this be sine or cosine? Well, we know that the graph of sine starts at middle. Remember, sine goes middle, high, middle, low, middle. Middle, high, middle, low, middle. So this can't be sine, so it must be cosine. You might be thinking, but cosine starts high, goes high, middle, high. I know, but this can't be sine because it doesn't start in the middle. Second, we must determine if a reflection has occurred, and this is where we address the fact that this starts low instead of high. Since the graph of cosine starts high, but this graph starts low, then a reflection across the x-axis has occurred. Third, we need to determine the period of the function, how long it takes for one cycle to occur. This cycle begins at x equals 0. You can see the x-coordinate on the first point, and ends at x equals 4 pi. So the period is 4 pi minus 0, which is 4 pi. It should be pointed out that in the future, the cycle will not always start at 0 because we might translate horizontally. And so the period will not always just be the x-coordinate of the point at the end of the cycle. Fourth, we need to determine the amplitude of the graph. The midline is the x-axis, so the amplitude is the distance from the x-axis to a high point or a low point. Either way, the amplitude is 2. Now, alternatively, we can calculate half the distance from the least to greatest y-coordinate. So the greatest y-coordinate is 2, the least is negative 2. 2 minus negative 2 divided by 2 is 4 divided by 2, which is 2. This will be more useful when the midline is not the x-axis after we've translated these graphs up or down. We can find the midline and measure from it, but really we just need the y-coordinates of the high and low points. We now know this is a cosine function with a period of 4 pi, an amplitude of 2, and a reflection across the x-axis. Recall that for the function f of x equals a cosine of bx, the amplitude is the absolute value of a, and a reflection across the x-axis occurs when a is less than 0. Well, our amplitude was 2, and we had a reflection across the x-axis, so our amplitude is negative, or a is negative, so that means that a is negative 2. Also recall for the function f of x equals a cosine of bx, the period is 2 pi divided by the absolute value of b, and a reflection occurs across the y-axis when b is less than 0. There is no reflection across the y-axis, so we know b is greater than 0. Truth be known, and I should have put a footnote here, there can always be a reflection across the y-axis because of the symmetric nature of the graph of sine and cosine. So unless we have a reason, we never go, well, there's a reflection across the y-axis. So we can usually always assume that b is greater than 0. Again, unless we're given a reason to think b should be negative. Now, because the period is 4 pi, we know that 2 pi over b equals 4 pi. Notice I don't have the absolute value because we already know that b is positive. Let's solve this for b. If we multiply both sides of this equation by b, it'll cancel the b on the left and give us 2 pi equals 4 pi b. Now if we divide both sides of that by 4 pi, we get b is 2 pi over 4 pi. The pi's cancel and it reduces to 1/2. Therefore, one such function is f of x equals -2, that was a, cosine of 1/2 x. There's actually an infinite number of functions that can do this, but you can read the footnote to see about it. Let's try one more, but more efficiently. Find a function whose graph is given below. Notice I have the relevant quarter period points labeled. Let's answer the 4 questions. First, is this sine or cosine? Well, this starts in the middle, so it's going to be sine. Second, was there a reflection? Sine goes middle, high, middle, low, middle, and this graph goes middle, high, middle, low, middle, so there was no reflection. That means our A is going to be positive. What is the amplitude? Well, it goes from 0 to 1, and the difference of that is just 1. Actually, that's the period. So why don't we erase that and put that in the period? See how easy it is to casually say one thing and think another? And I'm the quote-unquote expert creating the video, whatever that means. But our period is 1. The amplitude is the distance from the midline to the higher low points, or half the distance between the greatest and least y coordinates. 5 minus -5 is 10. 10 divided by 2 is 5. So it's a sine. There's no reflection. The amplitude is 5 and the period is 1. Now, because the period is 1, we got to do a little bit of work. We got 2 pi over b is equal to 1. And it shouldn't take too long to figure out that b is 2 pi. You can either multiply both sides by b and then that'll do it, or realize that a fraction is equal to 1 when its numerator is equal to its denominator. So now that we have all this information, and there's a comment about b being 2 pi, we can build our function. A was 5, b was 2 pi, and our function is this. F of x equals 5 sine of 2 pi x. Now you try. Pause the video and try the following. Find a function for the following graph. All right, here's your fair warning. If you have not yet paused the video, try solution in 3, 2, and 1. This is a sine, starts middle, but it does reflect because it goes middle low instead of middle high. The period is 6, from 0 to 6. The amplitude is 2.5. The period of 6 implies that b is equal to pi over 3. So our function is f of x equals -2.5, negative because of the reflection, cosine of pi over 3x.